Good morning, this is Mrs. Yule. I'm going to do my final video for this Future Cities work that we've been doing. I'm pretty excited about that. I'm also excited because it is all about trigonometry, which is one of my favorite math subjects. So we are going to be doing right triangle trigonometry, which is a fun word to say. You could practice saying it. And the central question is, what is trigonometry and how is it useful to me? Like, why do I have to learn trig? This is in the packet. I just wanted to read it to you because I think it's pretty important. So trigonometry sounds very scary and hard, but it really is not. We're going to do a short, friendly, and fun series of lessons for you. I have actually done one giant lesson for you, so if you want to do some of it and stop it and come back to it, that's fine. Trigonometry is a field of mathematics that plays an important role in a wide range of different careers. Architects, draftsmen, engineers in every field, so that means all kinds of engineers, field pilots, game developers, and even chemists are using trig. Trig is, simply put, the study of triangles and the lengths and angles of their sides. A working knowledge of trig and its uses is important to students of all ages. So we just finished all of the triangle stuff, and the reason the triangle stuff is important is because now we're going to use it in trig. So don't forget the Pythagorean theorem. It's really helpful here. We are only going to be doing right triangle trig. You can do trigonometry on any triangle, but for right now, we are focusing on the right triangles. So the first thing you want to do when you set up your problems is make sure that you have set it up so you have a right triangle. So a lot of new words in trigonometry. That is probably the hardest part for people. When I am looking at a triangle, here's my right triangle, so it's marked. Side opposite the right angle is the hypotenuse. And now we have this new weird letter right here. This is a Greek letter theta. We use this in trig to mark angles. So instead of x or t, in trigonometry, we usually use this theta. So if I'm coming from this angle, I want to know which is the hypotenuse, what side is opposite my angle, and which one is adjacent. So the opposite and adjacent are never hypotenuses. It's either the leg that is touching. If I'm touching, I'm adjacent. If I'm not touching, I am the opposite side. We have 6 trig ratios. Remember, a ratio is just a fraction. They are called sine, cosine, tangent, cosecant, secant, and cotangent. We don't write those out, so we abbreviate sine to be this sin. Do not say sin theta to me. I really dislike that. So this sin is really sine, cos is cosine, tan when you say it would be tangent, sec is secant, and COT is cotangent. I will explain to you what they mean, but right now you need to know the abbreviation. So stop this, write it all down, and then continue. Here are the ratios that we are talking about for trig. Sine theta is the opposite side over the hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent is opposite over adjacent. So what I would do right now is just stop this, write these down, and then come back and I will make sense of them for you. So the sine, the inverse of sine, or the reciprocal of sine, sorry, not really inverse. The reciprocal is cosecant theta, which is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. So these are the reciprocal functions. Cosecant I could also think of as 1 over sine. Secant is 1 over cos, cotangent is 1 over tangent. So make sure you write all of that down before you go on or find it in your packet. Now we are going to use these right now. So I have a triangle that I want to talk about, and I want to look and see if we can figure out what sine, cosine, tangent, cosecant, secant, and cotangent are. So when I look at my triangle, remember, I usually label the angles by the capital letters. So this can be A, The right angle is usually capital letter C, although it doesn't have to be, but by convention, we usually name it by capital C. And then my other angle is B. Remember, my sides are just the lowercase letter. So opposite angle A is side A. Opposite C would be little c, and opposite B would be little b. When I look at these, C is always going to be the hypotenuse. That does not change. And I can pick to talk about the ratios either from angle A or angle B. If they don't tell me, and I could just pick and talk about it. So let's let A equal theta here. So angle A is my theta. When I look at this, I need to label opposite and adjacent. So hypotenuse never changes, but opposite A is side A. This is the one not touching, so this is opposite. And then B is the one that's touching, so it is the adjacent. So since I am coming from angle A, this one is adjacent, this is opposite. If I were coming from angle B, I would have to switch those two. So now let's find sine theta. So sine theta is equal to, I'm actually going to write all of these out. So sine theta is equal to opposite, whoops, it's not picking this one up. Opposite over hypotenuse, that was on the last page we have. Cosine theta is equal to, and we said cos is equal to adjacent over the hypotenuse. Oh, come on, pick up this line. Okay, adjacent over hypotenuse. And then we said that tangent of theta is equal to, tangent is opposite over adjacent, so let me get the opposite. And let me make one more of these while I'm on it. I need a couple more of these. I forgot that I was going to do these other ones. Okay, so if I'm going to pick this one, this is opposite. So tangent is opposite over adjacent. Now, I'm going to put equal signs by all of these because we're going to figure out what they are. So we said opposite is side A, so the ratio of this would be A over C, because C is always going to be our hypotenuse. Cosine adjacent over hypotenuse. So adjacent we said was side B, and hypotenuse is always C. And somehow I need another A. Let me see if I can just copy an A. Yes. And tangent is going to be, opposite is A. And that would be over adjacent, which is B. So they're just ratios. If I want to go through the rest of these, cosecant is just going to be equal to, let me write these all down. So the reciprocal, the ones I think of going together, sine always goes with cosecant. This is flipped upside down. Cos and secant go together. And tangent and cotangent go together. So really, when I think about these, we're going to run out of paper. So cosecant is going to be this flip. This would be the hypotenuse over opposite, which would be C over A. Secant is going to be hypotenuse. And let me clone this line. We do need 2 more of these. These are kind of fun to pull around, but they do take time. So this one is going to be hypotenuse over adjacent. So that would be C over B. Cotangent is going to be the reciprocal or that flipped. So it is going to be adjacent over opposite. So this would be B over A. They're kind of fun to do. If I go from another angle, remember if I switch angles, I switch the sides. And we'll look at that in just a second. So when it says evaluate the 6 trigonometric functions of any angle, this means find all of the ratio. Go ahead and write this problem down and then start on the whiteboard. I will do this problem on the whiteboard for you. Make sure you write it down first and then come on and look. So I am given a triangle. I always copy my triangles down when I'm doing trigs. So here I am going to mark the right angle. I know that this is side C. I'm going to label this as the hypotenuse. Here they marked my theta and they said this is 5 and they said this is 12. If I am coming from this angle, this is the opposite side. It is the leg that is not touching. And this is touching, so this would be my adjacent. So I can write these all down. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over my hypotenuse. And then tangent theta is equal to opposite over adjacent. Cosecant of theta is equal to my hypotenuse over my opposite. I am just flipping this. Secant is equal to my hypotenuse over my adjacent. And cotangent of theta is equal to adjacent over opposite. Let me add a theta here. So secant theta. So notice that we have 2 of the sides. We do not have the third. I'm going to go back and use the Pythagorean theorem that we talked about last time. So by the Pythagorean theorem, I know that a squared plus b squared is equal to c squared. I have a and b. I have the 2 legs. So 5 squared plus 12 squared is equal to c squared. 5 squared is 25. 12 squared is 144. So 25 plus 144 is equal to c squared. 169 is equal to c squared. I don't want to know what c squared is. I want to know what c is, so I square root them. C is equal to 13. So now when I look at this, the opposite is 12. So this is just going to be 12 over 13, which is my hypotenuse. Adjacent is 5. This is 5 over 13. Opposite is my 12. And my adjacent is my 5. I don't have to work at all to do these 3. I just flip my triangle. I just flip this ratio. So this is 13 over 12. This one is 13 over 5. And cotangent is 5 over 12. So once I figured out the first 3, the second 3 are super easy to figure out. So if you need to pause, go ahead and do it, catch up with me, and then come back. And we're going to do problem number 2. So problem number 2 says, I don't know if I'm in the way for you guys or not. I just have to keep moving myself so I can read it. So this says, in a right triangle, theta is an acute angle and sine of theta is equal to 4/7. Evaluate the other 5 trigonometric functions of theta. Go ahead and write this one down, and then when you're ready, come to the whiteboard, and we will do this problem together. So I am going to write down the given first, and I always draw a picture. So notice that they tell me that I have a right triangle. And theta is one of the 2 acute angles. I always use this symbol for angles. So I have acute angles, and I know that sine of theta is equal to 4/7. I'm going to draw a generic right triangle. As long as you draw a right triangle, it doesn't matter if the right angle is here or here. Just draw a right triangle, and you can pick what angle you want to be theta. So I'm just going to pick this one. Now, when I think about sine, I know that sine is opposite over hypotenuse. And they gave me the value. So the opposite side is 4, and the hypotenuse is 7. So this is opposite, it is 4, this is 7, and I don't know what this side is. So first thing to do is to find this side by the Pythagorean theorem. 4 is a leg, x is a leg. So I have 4 squared plus x squared is equal to my hypotenuse, which is 7 squared. So I have 4 squared plus, oops, let me go ahead and I'm going to subtract 4 squared from both sides. So I have x squared is equal to 7 squared minus 4 squared. X squared is equal to 49 minus 16. So x squared is equal to 33. Square root them. And x is equal to the square root of 33. You can leave this as the square root of 33. If you have a number that doesn't have a perfect square root, you can just leave it as a square root. So I'm going to leave this as the square root of 33. So sine of theta is equal to opposite over hypotenuse. They gave that to me, it's 4/7. So when I find cosecant of theta, all I have to do is flip this, so it is 7/4. Cosine is my next trig ratio. This is adjacent over hypotenuse. Adjacent, let me label these. Here's adjacent, here is opposite, here is hypotenuse. So here I'm going to say the square root of 33/7. The reciprocal function here is going to be secant. So secant theta is equal to 7 over the square root of 33. If you're in my advanced math class, you know I can't have a square root on the bottom, so rationalize it. The rest of you don't worry about that. Tangent is equal to opposite over adjacent. Opposite is 4. So I have 4 over the square root of 33. And cotan of theta is going to be this turned upside down. So I have the square root of 33/4. We found all 6 trig ratios, which is what they were asking me to do. Notice that these are fractions. These are just numbers. The thing that people forget about is that sine just gives me a number. Cosine just gives me a number. There's nothing magic about them. We write them as fractions right here, but they really are just a number. So going back to the smartboard, got this one done. This time we are not solving for a ratio. We're going to find what x is. And this is where I told you that sine of something, cos of something, they're just numbers, and we need to use that idea right now. So go ahead and write this down, draw the picture, and then meet up with me on the whiteboard. Okay. In this example, we need to find x, which is a side length. So I have a right triangle, and I know it's a right triangle because the right angle is marked. This is 30 degrees. This side is 8, this side is x. So remember, if I am coming from the 30-degree angle, I'm coming from this angle, this side is touching, so this is adjacent. This is opposite the right angle, this is hypotenuse. When I think about adjacent and hypotenuse, I have to think about which trig ratio uses adjacent and hypotenuse, and that would be cosine. So I could say the cosine of theta is equal to the adjacent over the hypotenuse. I'm going to fill in with the given. So this becomes the cosine of 30 degrees. Remember, this is just going to be a number. This is equal to adjacent, which is x, over 8, which is the hypotenuse. Now I'm going to put this over 1. So I have a fraction equal to a fraction. We did this earlier. Remember, when I'm solving for this, I am going to cross multiply. So this is going to say 8 times the cosine of 30 degrees is equal to x. You want to do this on your calculator. If you have a TI calculator, you need to go into mode and make sure you're in degrees, not radians. There's 2 ways that we can measure angles, and right now we're in degrees. Make sure you fix that. If not, and you're using Desmos, this is just a number. So you just go 8 times the cosine of 30, and you will get x is about equal to 6.928, or side length of x is about 6.9. So I can solve for a missing length. In fact, we're going to do that again in just a minute. Next problem is going to ask us to solve a triangle. And when I solve a triangle, I need to find all the angles and all of the sides. So here they're saying solve triangle ABC. Again, they tell me that A is 28 degrees. Here's my right angle. Side B is 15. They gave that to me, and now I have to find C and A. So please copy this down. Know that when it says solve, I'm going to be finding all of the angles and all of the sides. Switching back to the whiteboard. I'm going to erase this one and then copy down the new problem. So this one says solve. And what it means when I say solve a triangle is find all 3 angles and all 3 sides. Here is my triangle. This is A. This is B. They gave me that this was 28 degrees. This is side little c, little a, and they said b is equal to 15. So remember at the end, I want to say angle A, angle B, angle C, and then I want to say the sides A, B, and C. I can write down what they gave me. A is 28 degrees. Interesting, 28 degrees. C is the right angle, so it is 90 degrees. And they gave me little b, which is 15. So for B, I know that A plus B has to be 90. So 90 degrees minus 28 degrees, and angle B is going to be 62 degrees. Remember, the sum of the three angles has to be 180. If this is 90, the other two have to equal 90, so I can find it that way really easily. I cannot use the Pythagorean theorem yet because I only have one side. So if I start with what they gave me, let's find A. They gave me B and they gave me the angle. So I am going to say the tangent of theta is equal to, when I come from angle A, this is opposite, this is the adjacent. So tangent is equal to opposite over adjacent. So I can say the tangent of 28 degrees is equal to A, which I don't know, over B, which is my adjacent, and that's 15. Cross multiply. 15 tangent of 28 degrees is equal to A. So A is equal to 7.98. And I'm going to fill this in up here. Now, I only need to find sine C. I could use a trig ratio, which I think the book did, but I go back to the Pythagorean theorem. And I'm going to say that A squared plus B squared is equal to C squared. A, we just said, is 7.98. So 7.98 squared plus 15 squared is equal to C squared. So C squared is going to equal 288.68. I just squared them, added them together. Now I have to square root. And C is going to be about equal to 16.99. So here is the triangle solved. You have all of the sides and all of the angles. Let's see what else we have to do. I think we're almost done. I think we have two more things just to encourage you on through this. So we solved it. Now we find a lot of actual real world solutions using trig. They used to find heights of mountains, heights of trees, heights of buildings using trigonometry. Now we probably use laser levels, but you can do it using trig. So the angle that an upward line of sight makes with a horizontal line is called the angle of elevation. When you're solving problems, you really care about angle of elevation and angle of depression. Let's do angle of elevation first. So when I am looking up at the top of something, angle of elevation is the angle between my looking up and the ground. You're always going to assume that trees are straight, buildings are straight, and the ground is straight. So I'm measuring the height of a spruce tree. I'm standing 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree, and it is 59 degrees. Find the height of the tree to the nearest foot. What I always make people do when they do these is to actually draw the picture. Even if it's done in a book, I think it's really fun to draw. I am not a very good artist, but it's okay. So here I am standing on the ground, and I'm looking up to the top of a tree. And I assume that the ground is level. I know that the angle of elevation is equal to 59 degrees, and I know that I am 45 feet away from the tree. And I want to know this height here. If I'm coming from 59, my angle of elevation, this is my adjacent, this is opposite. When I think about opposite and adjacent, I know I'm going to use tangent. So the tangent of theta is equal to opposite over adjacent. Here, my angle is 59, so I have the tangent of 59 degrees is equal to the opposite that I don't know over 45. Again, we simply put this over 1 and cross multiply. 45 tangent of 59 is equal to the height of my tree. And my height is about equal to 74.89. Do not forget the units. This was feet, and I know this is going to be feet. So I need feet in my answer. Or I could say the height is about 75 feet, or the tree is about 75 feet tall. So angle of elevation is pretty easy. Oops, I forgot to turn on my camera for the whole time. Let me go back and turn this on and I'll talk you through it again. You probably wondered what I was doing and we're going crazy trying to see it. Okay, so let me talk you through it. Here is my beautiful picture. 59 degrees, I labeled 45 from me to the tree, and H is the height. Here's my adjacent, here is my opposite. Tangent of theta is opposite over adjacent. Fill in what I know. Tangent of 59 is the opposite over adjacent, H over 45. Cross multiply, 45 tangent of 59 is equal to H. When I multiply this on my calculator, H is about 74.8 feet, or the height of the tree is 75 feet. Hope you got all that. Sorry, I forgot to turn it back on. Now, last thing is back to angle of depression. So this is when I look up at something, but I can also look down. If I'm in an airplane or if I'm in a balloon, hot air balloon, I'm looking down. Here's this solved here too. So if you want to look at the way they did it, it's exactly the same. You can go ahead and stop and have a look at this one. When I'm looking downward, I have an angle with a horizontal line, which is called angle of depression. This is harder for people to get. A lot of people want to make this angle right here be the angle of depression. It's the one right here. So I am parallel to the ground, but I'm up in the horizon. So notice I have a right triangle. We're assuming once again that things are straight and level. So I'm skiing down a mountain with the altitude of 1,200 feet. So from the top to the bottom of where I am is 1,200 feet. Angle of depression is 21. Find the distance. So now I'm looking for this X. This is the side opposite the hypotenuse, so opposite the right angle, so it is the hypotenuse. I am going to switch this time to the whiteboard. If you want to stop right now and write down the problem, do so, draw a picture, and then come back. Okay. Here I am skiing, which is so exciting. Here's my skis. And I'm looking at going down this mountain. Fortunately, I'm a really good skier and I'm not very afraid because 1,200 sounds like a huge number to me. This angle of depression is 21 degrees. Here's my right angle and I am looking for this. This is the hypotenuse. And this one is the opposite. When I think about opposite and hypotenuse, I know I need to use sine. So sine of theta is equal to opposite over hypotenuse. Here I have the sine of 21 degrees is equal to 1,200 over x. Cross multiply, now I get something really weird. I get x sine of 21 degrees is equal to 1,200, and it's actually feet. So now I don't know how to multiply x and sine of 21. Remember, I need to get x by itself. So this time I'm going to divide by the sine of 21 degrees. So I'm going to get x is equal to 1200 divided by the sine of 21, which you can just do on your calculator, whether you're using a TI or decimals. And for this one, you're going to get, this is about 3348.51. The units are feet. So I am actually going to be skiing about 3,349 feet down the hill. That's what they were looking for there. And one more time, back to the whiteboard. I think this is it. Let me get out of the ginormous board. Here we go. And let's see, I think that's all I had for you. Oh, here's the solution for that, and they did get the same thing. So we are done with the notes for trig. Remember, this is just a really brief introduction for you. Hope you enjoy doing it. It's kind of fun to do, and I just really want you to be familiar with how to set up the ratios and how to use the trig. Have fun doing this, work on your project. I'm looking forward to seeing all of your models. That'll be fun to see. So I'll talk to you later. Bye.